All right, it's 5:30. Thank you so much for sticking with me here. I know it's late in the day. I'm sure it's been a long day for you. It has been for me. We'll do one more session, and then we're done. See you here again bright and early tomorrow morning. My name is Philip Heedy. I'm Senior Product Manager for ArcGIS Enterprise. And what I'll be talking about here for the next hour or so is how to architect your deployment of ArcGIS Enterprise. So this is one of the less GIS-y and developer-centric talks you'll probably see here at the conference. This is much more about system architecture, how to architect your deployment, of course, also a little bit about how to install the software, configure it, and the various options for doing that. So my assumption about who you are is, regardless of what your title is, that you're somehow involved in that process. Either the initial system design and architecture, or the installation of the software, or perhaps even both. This is not about how to develop applications on top. There's lots of other sessions about that. I'm going to assume that you know what ArcGIS Enterprise is in the sense of that it's related to ArcGIS for Server. We made some name changes around 10.5, but I'll dig into a little bit of that. I will give a bit of a primer so we're all speaking the same language and hopefully have the same terminology. If you're already familiar with ArcGIS Server, in the sense of you know things of what a site is, it'll be a lot easier to follow what I'm talking about. If you also have some familiarity with Portal for ArcGIS, that's even better, but if not, I'll try to bring you along. This is a pretty big topic. We get a lot of questions on this at Esri from partners, customers. How do I architect my deployment? How do I put the software together? In fact, what are the software components? How do they fit together? How do I scale? How do I get high availability deployments? And I often get the impression that many people are a little bit overwhelmed. So I want to start off by saying, don't panic. We will get through this together. Hopefully, over the next hour or so, I'll give you enough information to be armed to go back and make some much better decisions about how to architect your deployment. What I'll be talking about here in this session today is what we refer to as our Web GIS pattern, meaning this is not about standalone ArcGIS Server, the traditional ArcGIS Server deployments of the past. This is about the full ArcGIS Enterprise, which consists of not just the server, but also Portal and data stores and all these other things. So that's the focus of what I'm looking at. So let's talk ArcGIS Enterprise. ArcGIS Enterprise as a product consists of 4 software components. Portal for ArcGIS, ArcGIS Server, ArcGIS Data Store, and last but not least, ArcGIS Web Adapter. One thing you should notice here is that although we introduced the ArcGIS Enterprise brand at 10.5 here 14, 15 months ago at this point in time, all of these software components existed before that as well. A big part of the ArcGIS Enterprise brand introduction at 10.5 was really to signify that the intended deployment of the product is that full stack. We want you to deploy the full stack because that's what all of our applications build on top of. It's what all of your applications that you will be building using the knowledge you gain here at the conference, using our APIs and SDKs, will also be building on top of. It's the stack that supports all of our newer functionality. So what does that mean? Well, we did a couple of other things at the same time. So we have 4 software components. One of them is the most well-known that many of you have probably been using for years. It's the ArcGIS Server software component. We made some changes around licensing as well that has an impact on system architecture that you should keep in mind, and also has an impact on some of the newer functionality that came in. So one of the things I want to highlight, because it's, again, a source of confusion, especially if you've been with us for a number of years, is that we've got this one software component. That's the thing you go to My Esri, or wherever you get your Esri software from, and download. It says ArcGIS Server. It's where you have an installer. You can run the installer, install the software on a machine, and then you have an ArcGIS Server installation. Well, that ArcGIS Server installation doesn't do anything until you apply a license to it, right? And essentially, we've got 4 different combinations of functionality that we call server licensing roles. So once you apply one of these licenses to your ArcGIS Server installation, that ArcGIS Server becomes a specific type of server. It has a certain role, a mission in life. The first one is the GIS Server. And this is what many of you will probably think of as traditional ArcGIS Server-like functionality. Ability to publish map services, geoprocessing services, feature services, and so forth. Then we have two other server licensing roles that used to be extensions. GeoEvent extension is now GeoEvent Server. Image extension is now Image Server. From a system architecture perspective, what that means is you can start scaling these independently, also not just from an infrastructure perspective, but also licensing. Last but not least, we introduced a brand new set of capabilities with 10.5 called GeoAnalytics Server. So this was a new server capability for doing big data processing, essentially. Batch analytics on large volumes of data using distributed computing infrastructure. So there's one software component that can do many different things depending on what you tell it to become. So when we talk about ArcGIS Server, it's typically because we're talking about a generic piece of functionality or some configuration or behavior that doesn't need to be specified which type of server it is. It applies to any one of these four roles. If I talk about a GIS server or a GeoEvent server, it's because there's something unique to that. To my GeoEvent server, that's the type of server that can do real-time data ingestion and processing, archiving, and things like that. All right. Another thing we did as part of the ArcGIS Enterprise introduction at 10.5 was to introduce a new concept called the base deployment, or the base ArcGIS Enterprise deployment. And this was to help answer the question of, well, you've got all these software components. Which ones do I need? Do I just use the server? Well, I already said no. It's a system that's designed to use the full stack. Do I need this data store thing? In fact, what is that data store thing? What does it do for me? Does it replace anything existing? Is it new? So the base deployment is intended to help answer that question. It is exactly what it sounds like. That is the minimal configuration of ArcGIS Enterprise software components to build a functioning system. By no means is it the end of the road. It's just the minimal configuration, and then you can expand out from there. You can expand out with additional GIS server sites. You can add more functionality through those other servers that I just talked about. So what does the base deployment consist of? Well, first of all, there's one of those ArcGIS servers. It's a GIS server that gets designated as what we call the hosting server for the portal. And I'll talk a bit more about what that means in detail. Also part of the base deployment is the portal itself. Portal for ArcGIS is the software component. So before talking about Portal for ArcGIS specifically, let me just go one step back and notice that many times you'll see us talk about ArcGIS Enterprise as a whole. In fact, for the most part, when we're talking about user-facing functionality, we don't talk about all the individual components. Just like most of us probably don't think about the fact that when we open up Outlook, if that's your email program of choice, there's an Exchange server sitting on the back end. Or if you're a little bit more modern these days, maybe it's Office 365. But for the most part, we don't know or care what powers that thing. Just like most end users really don't care what's powering that application on their iPhone, or what's powering the website that they're going to. So when we talk about something user-facing, we talk about ArcGIS Enterprise because that's the collective whole. We talk about the ArcGIS Enterprise portal, or just the Enterprise portal. When we're talking in the context of system architecture, design, or administration, well, you all know that there is some software that actually goes on some machines, some VMs, some cloud instances, whatever it might be. And at that point, we do have to talk about the specific software components. What is running where? How is it configured? How is it hooked up? But that's unique to system administrators. You have to know and understand all of those details. Traditional end users don't. So when I talk about the software components, that's because we're specifically in that realm. Otherwise, you'll start seeing us not really refer to these components by themselves. In fact, you will already have seen lots of Esri documentation and of our applications. In many cases, they used to say log into ArcGIS Online or Portal for ArcGIS. Now they say log into ArcGIS Online or ArcGIS Enterprise, because Enterprise is the front-facing thing. Behind the scenes, there's certainly still something called Portal for ArcGIS, because that's a software component that you install. And it provides the web front end, the website itself that you can go to. But it also provides a lot of back-end APIs. Those back-end APIs, of course, power the web front end, but it's also what powers all of your applications. When you log in, users, groups, all of that is powered by a REST API on the back end. So the portal certainly also provides that application framework that we can all build on top of. Also part of the base deployment is a software component that will be new to many of you if you haven't already worked with portals. In this case, it's called ArcGIS Data Store, and it's a managed data repository for data that's copied over to the system. I'll talk more about this in just a second, but one of the things that's really interesting about the Web GIS pattern is the ability to provide self-service mapping capabilities to a lot of users who haven't traditionally done GIS-style work. But when those users come in and then drag and drop a CSV file onto a map inside of that web application, well, that data has to go somewhere. Where is that somewhere? It's probably not your traditional enterprise geodatabase, because at some point you'll get really upset with us if we create hundreds of feature classes to store all those CSV files and Excel files. So we needed a place to put that data. And well, that place is the ArcGIS Data Store. That doesn't mean it replaces your enterprise geodatabase. Far from it. That's still where you can create, maintain, and update all of your authoritative data sets using advanced features like topologies, versioning, and so forth. ArcGIS Data Store is about data that gets handed over to the system. We need a place to store it. When you run an analysis from within the portal map viewer and create a buffer, well, that data again has to be stored somewhere, because it's persisted and made available as a new hosted feature layer. And again, that somewhere is the ArcGIS Data Store. As opposed to giving you back a zip file of a file geodatabase, well, it became a new REST service that you can hit and use. And the data store powers that on the back end. So everything I just described is actually what we refer to as the relational data store. Think of it as a relational database that we use internally to the system to handle all of the data that you hand over to us or we generate on your behalf. But ArcGIS Data Store has 3 different types of data stores that you can configure. Just like ArcGIS Server has different roles, there's different types of data stores coming out of the one ArcGIS Data Store software component. Part of the base deployment is that first one that I just talked about, the relational data store. There's also another one called the tile cache data store. What this actually provides is the ability for us to store 3D tile caches. So when you publish a scene layer, if you're familiar with map services, when you cache map services, we write bundle files on disk, and we've been doing so for years. Well, for scene layers, we don't write bundle files on disk. They're written into the tile cache data store. So that's what that powers under the hood. Now here in this slide, there's another third one, grayed out. It's the spatio-temporal big data store. The reason it's grayed out is it's not part of the base deployment, but it's something you can add later on if you get into some of the more advanced functionalities such as GeoEvent or GeoAnalytics. And I'll talk more about that here at the end of the presentation. And finally, we have the ArcGIS Web Adapter. That's also part of the base deployment. Think of it as an Esri software load balancer that we use to direct traffic to the right internal components. And it's also where we do a lot of our security integration. So it handles a lot of configuration that we would otherwise have to rely on you to do in things like reverse proxies and doing things that in many cases can be quite difficult. So we get a question often that, do I have to use the web adapter? And the answer is yes. For your own good, please do. It will simply make things a lot easier. That doesn't mean you can't still also use your own external load balancers, if you have hardware-based ones, reverse proxies, whatever it might be. But it simplifies a lot of configuration options and provides the ability to integrate with things like integrated Windows authentication, PKI, what we refer to as web tier authentication methods. All right, so that's what ArcGIS Enterprise consists of, software components. The idea of the base deployment itself is the configuration of these different software components. If you're coming from an existing ArcGIS server deployment, you're most likely coming from something that looks similar to what's on the left-hand side. You probably have a web adapter and sitting in front of an ArcGIS server site. Maybe there's one or more machines in that site, but typically it's a fairly simple thing from that perspective, at least on a logical architecture diagram like this. Now, when you're moving from that kind of deployment to the base ArcGIS Enterprise deployment, well, you'll notice that there's some more components now. So now we have to figure out how do we go from one to the other. What does that entail? So let me dig into the base deployment one more time and just talk through what's actually there and how to go about it if you were to do it by yourself. So first of all, we've got those web adapters, right? They're sitting and directing traffic coming in from the outside into the individual components. There's one web adapter for the portal, and there's one web adapter for that hosting server, the ArcGIS server that's been designated to be the hosting server. The portal, as I mentioned, is that front end for the web application that's often, at least internally to Esri, referred to as the home app when you log into the portal website, and that back-end API. The base deployment then has this thing I keep referring to, the hosting server. It's licensed as a GIS server, which means that it provides the ability to still publish out your own map services and feature services and geoprocessing and geocoders and whatnot. What it also supports is that self-service mapping, right? So I talked about dragging, dropping a CSV file onto a map. The data has to go somewhere, and that somewhere was the data store. Well, there also has to be a place where that REST endpoint comes to life. That's the hosting server. We host something on your behalf. And sitting underneath the hosting server is ArcGIS Data Store, specifically the relational and tile cache data source. So this is the authoritative look on what the base deployment looks like. What you'll notice is here at this level, there's no indication of how many machines are powering the base deployment. Right? We've got a number of components and they're connected up to each other in certain ways, but you could deploy this on one machine, all the components on one, or you could be splitting it apart into multiple machines. We'll talk a bit about that. Now, everything that I just talked about is also laid out in the ArcGIS Enterprise documentation. And I need to update my screenshots because the ArcGIS Enterprise documentation actually got a bit of an overhaul and a facelift here with the 10.6 release, not more than a month and a half ago. So if you have questions about what I just went through, you want to refer back to it, you want to point other people within your organization, go to enterprise.arcgis.com, find the ArcGIS Enterprise overall publication, and that's where you will see all these definitions of the base deployment, its components, and so forth. So what can I do once I have the base deployment in place? Well, first of all, you can do everything that traditional ArcGIS Server did. No functionality has gone away. So you can publish your map services, feature services, and all those things. You can publish your content from reference data sources, meaning you don't have to copy the data to us. You can point us to where it is in place, whether that's an enterprise geodatabase or a file-based data source, like a file geodatabase or shapefiles. Any shapefiles users? Nobody wants to? One. We should talk later, but that's okay. It's not bad. But the base deployment then also gives you the option of providing self-service mapping to your users. Whether those are GIS analysts who also use things like ArcMap or Pro, but certainly also a much broader set of users who haven't traditionally done mapping themselves. So this is a new thing that's part of the Web GIS pattern. The ability to give people a way to create their own maps. You can still provide them all of those base information products, your map services, things they can layer on top of, but make it really easy for me to take that Excel spreadsheet that's been sitting on my desktop and overlay it on top of everything else that you've been providing, as opposed to having to get that call or email and say, well, I'll get back to you and I'll send you a PDF in a couple of days or weeks. And along with that comes the ability to make use of all of those other things that we keep cranking out here. Story maps, configurable app templates, so you don't have to build custom applications for every single thing. You can use Web App Builder to create applications yourself if you need a little bit more flexibility. And then, of course, you can also use all of the other apps that we've created, native apps, or all of those custom apps that you do want to still create. But save your firepower for custom apps for the stuff that really matters, as opposed to the simpler things that can be taken care of by existing templates or something like Web App Builder. Okay, so that's what the base deployment itself powers. Everything traditional server has always done, plus a lot of new functionality and serving as that application framework to build on top of. So how do we get it set up? Well, step 0 that I didn't really include here is install the software, meaning run through the software installer, next, wait for it to complete. Then the next step is configuring the web adapters, hook them up to the server and the portal, configure the data store, register it with that hosting server to be. Remember, that's the relational and the tile cache. Federate the server with the portal itself, and then designate it as the hosting server. Tell the portal, this is your hosting server. This is where you need to send stuff when somebody uploads to you. And conceptually, that's really it. Now, the devil is, of course, in the details, so that's why we're here. If you want to see the steps, the individual steps for doing this by hand, we have an entire tutorial within the ArcGIS Enterprise documentation. So again, go to enterprise.arcgis.com and find this tutorial, and it'll walk you through step by step on installing the software, configuring the software afterwards, those individual things that I just went through. Now I'll give a little preview of something that I'll say later on. There's lots of other ways of also installing the software these days. Installing the software and configuring it by hand is really not anybody's idea of good fun, I'm guessing. There's lots of automation tools that we provide, and I very strongly encourage you to look at that. And I'll talk a bit more about that later. So now we get to some of the meat of system architecture. I mentioned before that so far the diagram hasn't really said anything about whether to install all of the software on a single machine or multiple machines. And that's really your first big decision before you actually get into installing the software. Now, I often get questions on this choice phrased in the way of, well, Esri best practices tells me that I should be installing the software on separate machines. And I look at them and ask, well, where did that best practice come from? Because I am a big part of defining that, and that's not necessarily true. It all depends on your specific needs and requirements. Do not assume that you have to. My point here is to stress that I think that all-in-one base deployment is vastly underutilized. Do not complicate your life unnecessarily. If you have the need to scale out to meet significant demand, or you fear that you might have to do that in the future, by all means plan for it. But the all-in-one base deployment can be a great thing, not just for things like dev and test environments, but certainly also for small to even medium-sized deployments. Consider this carefully as you look at how to set things up. I can't answer it for you, but I can definitely encourage you to consider the all-in-one deployment, unless you know you will have to scale to meet hundreds of map services being continuously used by hundreds or thousands of users on a regular basis. Okay. So once you make that decision, then you start looking at the individual software components themselves. How do I scale them out, if need be? And this is where the different software components behave in slightly different ways. The portal software component really doesn't need to be scaled out that often. In fact, it's been very rare that I've talked to somebody where that turned out to be the case. The portal software component is relatively light in the sense of compute that it requires. It requires a decent amount of memory, but compute is not typically a bottleneck. If you have to scale out, we do not scale out the portal component horizontally, meaning we don't scale out by adding additional machines. You will have to scale up vertically by adding more resources to the machine or machines where it's running on. Now, I mentioned potentially multiple machines. We support a 2-machine setup for the portal for purposes of high availability. It's not for the purposes of scaling out. Do you get a little bit of scale out by doing this? Certainly, but that's not its main purpose in life. Its main purpose in life is to provide HA, not more capacity. So keep that in mind. When we move on to the next tier, we're looking at that hosting server. So if you look at the hosting server in the base deployment, well, it's performing multiple distinct duties, right? It's just a traditional GIS server, which means you can publish all of those map and image services and geoprocessing and whatnot. But it's also serving as the hosting server, which means it powers those hosted feature layers. It also powers those analysis tools. So again, if somebody goes in to the portal map viewer, clicks the analysis button and creates some buffers, well, there's some compute that has to happen somewhere to actually generate those buffers, or whatever the analysis is. And that somewhere is the hosting server. So it's doing multiple different things. And one thing to consider, instead of necessarily scaling out the hosting server, is do you need to start thinking of things like workload separation? And we'll talk much more about that here in just a second. Workload separation is really the idea of creating separate pieces of infrastructure, in this case separate ArcGIS server sites, for specific workloads so they don't compete for resources. You don't want your map services to all of a sudden be negatively impacted because somebody is running a lot of analysis. When or if you decide to scale out ArcGIS Server, well, you can do it in one of two ways. You can, of course, add more capacity to the existing machine or machines. But ArcGIS Server does scale out horizontally. You can add more machines to the existing site, so you have a multi-machine site, and we've been able to do that for many, many years, and that hasn't changed. This is where it gets important to have thought of that prior to the initial setup of the base deployment, because if you installed everything on one box, well, now you might be adding an extra machine to that hosting server site. Now the machines aren't equal, right? One box is running portal and server and data store, and now there's another machine just running server. It's probably not what you want. So that's where you have to start planning ahead of time. But you can certainly scale out ArcGIS Server by adding more machines for that horizontal scaling. And then there's the ArcGIS Data Store. This is a pretty busy slide. That's not because I want to necessarily talk through every single piece, but also because I want you to be able to refer back to this after the presentation. And anybody who's interested in the slides, they will be made publicly available as well, so you don't necessarily have to take all the pictures. So remember, the base deployment consists of two different types of data stores powered by the ArcGIS Data Store software component. There's that relational data store, which powers hosted feature layers. That's where the data goes into. It also powers a lot of functionality for something like Insights for ArcGIS, which was a new application introduced alongside 10.5. So that's something to keep in mind. Again, what does ArcGIS Data Store need to perform well? Well, it's a database, which means it's memory, CPU, and disk I/O. But it all depends on what kind of load you're putting to it. If you really don't expect to have a lot of self-service mapping, or they're all small data sets that don't get that many hits, you may not have to worry about this too much. If you have a lot of data, or maybe you have a lot of Insights users, well, Insights tries to be as efficient as possible and pushes as much analytics as it can down to the underlying database. So Insights can start making a lot of use of this particular component. So you have to monitor for all three of those different things. But disk I/O, the simple thing to do there is put it on fast disks. What are fast disks? They're SSDs. Goes for any kind of database. ArcGIS data store is no different. I mentioned the tile cache data stores. That's where scene layers store their 3D tile caches. So that's something to think about from the perspective of when you publish a new scene layer, we cook a 3D scene layer cache under the hood, which means there's some work being done on the data store at that point in time. Once it finishes cooking, the tile cache is a relatively lightweight component. The tile cache data store really just streams data back. So it needs to be able to read data and then streams it back. It's not very compute intensive at all. But that initial cooking, you might see spikes on the machine or machines powering the tile cache data store. At the end of the day, you need to monitor for bottlenecks. And the obvious bottlenecks to keep an eye out for are memory and CPU, but also disk I/O. One way to do that is using a tool like ArcGIS Monitor, new tool that was just made available here alongside 10.6. It's based on System Monitor, which has been around from professional services for a while. So that's important. And then there's a little mention about pre-10.5.1 versions. You need to be careful about things like monitoring. Databases don't like it when you run out of disk space. That's an unfortunate state of affairs, and you should avoid that happening in the first place. But if it does, we also want to be resilient. So we had some issues that we fixed in pre-10.5.1 versions. All right. So now we have a base deployment in place. We've made a decision on whether we did an all-in-one or whether you decided to give multiple machines and one machine per component. Maybe you still put some components together based on what you think you need now and the ability to scale out in the future. So before talking about expanding out from the base deployment, I want to make especially one point very clear. There's a common question that I also get is that, can I have multiple sites, multiple ArcGIS server sites with a single portal? And the answer is an unqualified yes, you absolutely can. You can federate as many sites as you need or want to a single portal. So you're not limited in any way in that sense. And then the different server roles, GIS server, image server, and so forth, have different recommendations and restrictions that I'll go through now. So that's something to keep in mind. I already touched on this first point. So expanding out from the base deployment, one way to do that is adding additional GIS server sites. This is typically where workload separation comes in. I have my hosting server, but I want some dedicated infrastructure for all of those map and feature services and everything else, so they don't compete for resources with the hosting server and everything else that it does. You're not adding additional functionality to the system, but you're separating things out from each other to avoid resource contention. You can have many different GIS server sites, and there's many motivations for doing so. We'll talk about that. Then there's also expanding out by adding additional capabilities, something that's not part of the base deployment itself. This would be adding an image server site, adding a GeoEvent site for real-time processing, or adding GeoAnalytics for doing batch processing. So let's go through those 4 different server roles one by one to see what that actually means in practice. First of all, remember you have a GIS server site. You might consider adding additional ones for workload separation in particular. Some common workloads that often drive this decision are highly used sets of dynamic map services. Dynamic map services are those where the map gets drawn for each request. That's a CPU-intensive thing, so it often makes sense to isolate those off if you have many of those or ones that are highly popular. Things like geoprocessing has a tendency to be potentially both CPU-intensive, doing a lot of processing, analysis, compute, but also writing data to and from disk, creating new things, which means disk I/O. A lot of times those jobs run in seconds, but maybe even minutes or longer. If that's the case, it can make a lot of sense to have a GIS site dedicated for that purpose. And there's lots of other things. Routing services are generally fairly CPU intensive as they trace through the network and figure out the optimal route. Mission critical things that you need to isolate off from other less important things for separate SLAs can be a reason for why you want to add additional sites. The way that looks on a logical system architecture diagram is something like this. You've got your base deployment, those web adapters, the portal, the hosting server, your data store. And then you're simply adding another ArcGIS server site. You're not adding machines to the hosting server, the site that's already there. You're creating a brand new site. You might do that, one, to get those mapping, whatever services isolated off. But you could keep going. It all depends on your particular needs and whatever other restrictions you might have, whether those are infrastructure or licensing restrictions themselves. But you can keep going as needed and as desired. So in this case, we have 3 different ArcGIS server sites. The hosting server from the base deployment, a mapping and visualization site for our map and feature services, and then a site for your geoprocessing services. So let's take a look at image server. How do we add image server into the mix, and what does that even mean? Well, first we have to talk about what functionality image server provides. There's what I would term traditional image server functionality, which are those dynamic image services based off your own mosaic data sets. This is the image equivalent of a map service. It draws an image, a raster, potentially with some raster processing being done on the fly. You can define these long, very advanced raster function chains and apply that in real time. So when I'm panning around, it applies that raster function chain to that one request at screen resolution, and it's sent to my device. It's not persisted anywhere. Every time I pan, it draws it again on the server side. New at 10.5 was the introduction of raster analytics, which is the raster and imagery equivalent of GeoAnalytics. GeoAnalytics is for vector data. Raster analytics is a part of image server and deals with raster and imagery. This is about being able to apply those same raster function chains, but to run it against the raster and imagery at source resolution and persist the results as a new derived product on disk, or wherever you're writing to. It can be cloud stores as well. So those are 2 very, very different ways of looking at similar functionality, but one is persisted, one is not. One is small area, one is potentially large area, your entire mosaic data set, or a lot of pixels, right? So it's about being able to process those potentially billions and billions of pixels very quickly across many machines in the case of raster analytics. So adding image server to your deployment can look like this. You already have your base deployment, now you're just adding an image server site. And this would be a very nice architecture for when you're looking for those traditional dynamic image services. If you want to do raster analytics, my recommendation would be to have a separate site dedicated for that purpose. Again, because raster analytics is about processing large amounts of pixels quickly across as much capacity, as much infrastructure as we can, well, it's designed to use as much memory and CPU to get the job done quickly. You don't want to commingle that with other services, because otherwise things will start slowing down as you're processing those large raster analytics jobs. So this is how you would do that. The reason I call out raster analytics is also because from a system architecture perspective, you can only have one raster analytics site. When you submit an RA job to ArcGIS Enterprise through Pro or the map viewer, that one site that you've designated as the raster analytics site is where that job gets sent to be processed. It's the Highlander model. There can be only one. You can see who's watched their old 80s movie and said, good. On the other hand, you can have as many image server sites as you want that are not for raster analytics. You can split out your image services in different buckets as desired. Okay. I mentioned GeoAnalytics Server before. This is about vector and tabular data. Again, large volumes of data that I want to process using many machines, many cores, a lot of memory. This one also follows that Highlander model of there can be only one GeoAnalytics Server site in an ArcGIS Enterprise deployment. When you submit a GeoAnalytics job, this is the site that picks up the job and does the processing. Now you have to do more than just add a site for GeoAnalytics to your base deployment. You also have to add another component. You have to add the spatio-temporal big data store. So the spatial-temporal big data store is a data store optimized for receiving and storing large volumes of data, much larger than what you would traditionally do inside of a normal RDBMS. So you have to think about how to scale both the GeoAnalytics site, the compute side of things, as well as that spatio-temporal big data store, which is the storage side of things. There's a lot of variables that go into sizing a multi-machine deployment of GeoAnalytics. This is not, we could have an entire session just on this one topic by itself. Here are some of the variables. And the reason I list out all of these is to get you thinking about if you're looking at GeoAnalytics or you want to do some big data processing, this stuff really matters. There's a huge variety of different types of data. There's flat files like CSV files that can be sitting on a file share, sitting in a cloud store like S3 or Azure Blob Storage. There's HDFS and Hive, lots of variation. They all behave differently. It's also about how can we get that data from wherever it is to our compute machines. Can we do it fast enough? Do we have high or low latency networks? Do we have high or low bandwidth? It's actually not uncommon to saturate a network if you have large enough data and enough compute to handle it. If you can't get the data to the machines doing the compute, it doesn't help to add more cores. Often I get the question, well, I want it to go faster, I'll add more CPU. Well, it doesn't help if we can't keep all those CPUs busy actually doing processing. If you can't read the data fast enough, that's not the bottleneck you're looking for. So again, things like disk I/O, if you're hosting data on your own drives, starts to matter. You also need to have that right ratio of CPU cores to amount of memory. That goes to keeping the CPUs busy as well. A lot of the advantages of things like GeoAnalytics and the underlying architecture there, the software, is about doing as much in memory as possible. So if you don't have enough memory, you can't keep the CPU busy, and things don't go as fast as you want them to. You also have to be able to write out the results on an ongoing basis. So your spatial temporal big data store has to be able to keep up. The spatial temporal big data store scales out to any number of nodes. Adding more nodes gives you both resiliency, meaning there's now potentially multiple redundant copies of the data so you can withstand losing a node, but it also gives you the ability to write out data faster because we can write out data in parallel to all of those different nodes. So adding GeoAnalytics to the base deployment at a minimum looks like this. And it requires at least 3 machines total. It's the bare minimum. To do a 3-machine setup, you would have the base deployment all on a single machine. You would have a single node of the spatial temporal big data store, isolated off on its own thing, as well as a single node of, or single machine ArcGIS server side setup for GeoAnalytics. You can actually do quite a lot of powerful data crunching from a GIS perspective with just those 3 machines. You don't have to be thinking in terms of hundreds of cores or tens of machines to do some good number crunching. Now, if you do have truly big data sets, hundreds of gigabytes, terabytes, petabytes even, worth of data, you're probably not doing it with a single machine. In which case, you will have to scale out, adding multiple machines. And how many machines ultimately depends on those different variables, as well as what it is you're really going after. How quickly do you want to process something? If you're okay with waiting a day, you may need fewer machines than if you're looking for a result in an hour or in minutes. It all depends on your data and how big it is and where it's at. But ultimately, your diagram will look like this. You'll have to have a base deployment. You will have to have some number of nodes of spatial temporal big data stores and some number of machines in a GeoAnalytics site. Now, where did all of your big data for GeoAnalytics come from? Well, one potential way is to get a data dump. And surprising to me, at least when I first started looking at this, was data dumps of CSV files are shockingly popular in the big data world. Getting multi-gigabyte CSV files seems to be the thing that many people do, and I think that's lovely. The shape file of the big data world is CSVs. Who would have thought? But if you're not just getting large data dumps, one way to get large amounts of data really, really quickly is to ingest real-time data feeds. Ingest a real-time data feed that has a few hundred events per second for even just a couple of weeks starts adding up really quickly. So GeoEvent might be used to do just that. And of course, everything else that GeoEvent does, such as real-time alerting, acting on that data, not just storing it, but enriching it, sending out alerts, or many other things. Actuation commands to sensors to make them actually act on what they're recording. Adding GeoEvent Server to an ArcGIS Enterprise deployment prior to 10.6, the recommendation is to use single machine sites. Do not add multiple machines to a single GeoEvent site. There's some underlying challenges that we have with scaling out those machines that were addressed at 10.6 that just came out here a month and a half ago. So depending on what version you're at, the recommendation is a little bit different. Now, each machine in that setup has to be powerful enough to handle whatever your expected peak throughput is. So if you have a real-time feed that's very jittery, meaning sometimes there's few events and then all of a sudden it spikes, you need to be able to plan for that spike. To handle multiple input streams, you would have to add separate machines to separate sites to be able to scale that out. Now, when you're storing data that's pouring in through GeoEvent, the question is, how can I store that data? Well, GeoEvent can write into a traditional enterprise geodatabase just fine. But traditional RDBMSs often have a problem keeping up with the data flow once you get past a few hundred events per second. It's simply not what they're designed for. So once you get beyond a few hundred events per second, if you want to archive those large volumes of data flowing in, you will need to use the spatial temporal big data store. So this is the same component that GeoAnalytics relied on. So the minimal GeoEvent architecture looks like this. There's a pattern emerging. You've got your base deployment, and you will create a single machine GeoEvent server site that you federate with that portal. Now, if your real-time feeds add up to more than a few hundred events per second that you want to archive, you would add the spatial temporal big data store. It's not a requirement, but once you get past a certain point, it very quickly becomes the right thing to do. And again, the spatial temporal big data store by itself can scale to n number of nodes. Whatever is needed to meet your data storage requirements. Remember that data could be around for a long time, and you need to be able to grow to store all of it, as well as how quickly you need to ingest. If you start getting into the tens of thousands or hundreds of thousands of events per second, first of all, we should talk. But beyond that, you will need multiple nodes of spatial temporal big data store. To scale out pre-10.6, this is what it would look like. You would add additional single machine sites, but beginning at 10.6, and you can go to some of the GeoEvent sessions, get much more details, we do have an architecture that allows you to scale within a site by adding more machines, so you could scale out horizontally within a single site. So that's a relatively quick run-through of the different server roles and how they behave. So a little bit of a recap here is you'll notice there were different models, right? The GIS server, you can have as many as you want, and you can always scale it out by adding additional machines to existing sites, or scale out by creating completely separate sites for different workloads. Image server If you're looking for image services, behaves in the same fashion. You can have as many sites as you need. But raster analytics behaves according to the Highlander model of there can be only a single site. GeoAnalytics also has that kind of setup. There can only be one site for GeoAnalytics Server. And GeoEvent, you can have as many sites as you want, and for pre-10.6, meaning 10.5.1 and before, you should add multiple single machine sites if you need to scale out or handle more streams than one machine can do. So how do I deploy all of this? I sit down, I put together my system architecture diagrams, I figure out what I want to deploy, how do I do it? Well, the naive approach is downloading the installers and get cranking. Next, next, next on a whole bunch of machines, fill out the wizards, paste the right URLs, hope you didn't mix up the admin URL and the services URL as you were federating and keeping all that stuff straight. Who likes that process? All right. You also use shapefiles? Yeah. No, there's a lot more options than just doing it the old-fashioned manual approach. And I've been fairly blunt within Esri, and I'll be fairly blunt with you here as well today. I would argue that if you're doing it by hand, you're doing it wrong. Not because you can't, because it's just not efficient. If you're installing an all-in-one base deployment outside of a cloud environment, use the ArcGIS Enterprise Builder. It was a new installer that we introduced with 10.5.1, and it is exactly what it sounds like. It's a single installer that lays down all of the components and does all of the configuration as well. You answer a total of 6 or 7 questions, I believe, including hard ones like what do you want your administrative username to be, what do you want your password to be, where are your license files, and then you click go. And you walk away for 30, 45 minutes, you come back and you have a fully functional base deployment, the data stores have been configured, the server has been federated with a portal, the web adapters have been set up, and you're ready to go. And I challenge you to do that by hand. Why would you want to do that by hand? If you're deploying in a cloud environment, such as AWS or Microsoft Azure, we have deployment tooling specifically for those environments. We have pre-built machine images, AMIs in AWS, machine images in Azure, meaning we've already installed the software. We've already done some tweaks to make things run even better in those environments. And then we have tooling on top of those pre-built images. In AWS, those are CloudFormation templates. And we've got templates for a wide variety of different deployment patterns. And beginning at 10.6, we also have a new command line tool for orchestrating those things. Instead of you clicking through the templates, you can run a batch file of some kind to do the same thing for you. You should never install by hand in a cloud environment. You should never have to do the configuration by hand in a cloud environment. Outside of a cloud deployment, for those more advanced installations where you don't just have a single machine-based deployment, we have automation things like Chef. Chef is an automation framework. It's an open source automation framework where we have written what's known as a cookbook. They have a whole food theme going on. So I don't know about you, but we're getting close to dinner time. Chef has cookbooks. Cookbooks contain recipes. Recipes are actions, things like install this software component, perform this configuration step. We have written all of those recipes for you. And what you need to do is specify your run lists. Run lists are perform these actions in this series. That gets you very close to what's known as having infrastructure as code. 6 months down the road, when you need to explain to somebody else what you installed, instead of having to try to backtrack and figure out what's actually sitting on the machines, you simply look at your run list. There you go. And if you need to do it again, you just run it and you get the exact same thing as you did last time. No typos in any URLs or mixing up of admin and services and whatnot. In fact, we have another option coming soon that we're announcing here at the conference. Chef works equally well on Windows and Linux. It's an open source framework, but Microsoft has a similar technology, PowerShell DSC. So if If you're in a Microsoft-oriented shop, we will also start supporting that. That's in beta, coming here soon. And if you're interested, definitely let me know, and I'll get you in contact with the team that's supporting the early adopter program for it. So again, if you're outside of a cloud environment, Chef is the thing to look at if you want infrastructure as code for those multi-machine deployments. PowerShell DSC is a new and upcoming option for those of you in Microsoft environments where that's a better fit. I want to also quickly cover a couple of other important topics that are somewhat related to system architecture, and because sometimes best practices needs an update. So a common pattern, especially a few years ago, was what was known as siloed ArcGIS Server sites. Multiple single machine sites that all had the same set of services running on them. You put a load balancer on top into the outside world, it looks like a single logical thing. They have some nice advantages, but there's one big disadvantage, which is that they don't work in an ArcGIS Enterprise world, because you can't federate all those individual sites. You can't federate them because now they look to the system as exactly what they are under the hood, which are separate. They're not viewed as one single unit. Do not use clusters. Clusters has a very specific meaning inside of the ArcGIS Enterprise or ArcGIS Server world. So when I say clusters, I don't mean in the generic, general IT sense of multiple machines working together. That's what we call a site, right? An ArcGIS Server site is multiple machines. Clusters was an ability to subdivide a site into smaller logical units that we called clusters. If you use clusters today, stop. They were officially deprecated as of 10.5.1, and 10.6.x will be the last release series to support clusters. So if you have clusters, you need to start planning to migrate away from them. Otherwise, at some point in the very near future, you will not be able to upgrade until you do so. Instead of using clusters, use separate sites. So if you had a 4-machine site subdivided into 2 clusters of 2 machines each, the natural thing to do is simply to have 2 separate 2-machine sites. What was a cluster before should become its own site. So it's a relatively straightforward migration. In that sense, there's obviously a little bit more work to it, but it's something you need to look at. Do federate your ArcGIS Server sites. ArcGIS Enterprise is built on the federated model where the server sites are federated to a portal. It's what powers a lot of our new functionality, things like publishing from Pro. It's where you get the ability to use raster analytics with your image server sites, and the list goes on and on. That is the model that we're building all of our newer functionality in. Do use the web adapter. It's just easier for everybody. 2 other small things. These come up on a fairly recent basis, or often. One is that we are running into more and more customers that have this problem of not being able to either publish new services or run more service instances of existing services on a machine that doesn't appear to be out of resources. There's plenty of memory available, and yet for some reason I can't publish anything new. And the errors in the log files are often not that descriptive. Often they're just, there's something that failed to initialize. You're running into a Windows limitation. You're actually not out of memory, you're out of resources for the non-interactive desktop heap for the technically inclined. If you don't know what that is, you're lucky. Sadly, I do know what it is, but if you run into that kind of behavior, I want you to remember hearing me talk about it, and then you go to the support site and find this tech support article that tells you how to change some very arcane Windows registry settings, and life will be grand again. Your bottleneck should be the actual memory available on your machine and not this Windows limitation that happens to be just based on some defaults that can be changed. This is far less common, but on Linux there was a similar type of limitation at 10.3x. If you happen to be on 10.3x, you couldn't publish or run more than 250 service instances or SOC processes. upgrade to anything 10.4 and higher, and that is just not an issue anymore. There's an internal limitation that we lifted, so you shouldn't have to worry about it. Now, I'll leave you with this. I want you to, and I implore you to stay up to date on best practices. Best practices are not set in stone. As the software evolves, best practices evolve as well. What was a best practice on 10.2 is not necessarily a best practice on 10.6. In 2021, you're going to think back, and you should not be listening to Philip in 2018 at that point anymore. You need to stay current. So just because you know what best practices were in the past, you have to make sure that they're still applicable. As I mentioned, ArcGIS Enterprise is designed for the federated server model, so you need to understand what that means if you're not already in an ArcGIS Enterprise style setup. You should understand the base deployment. That's what forms the basis for everything else that we do. And then, of course, as you're looking to expand out with additional capabilities, keep in mind that the individual server roles, even though they're all powered by the same one software component, they do behave differently. And with that, I'm back to where we started. If that seemed overwhelming, I hope it didn't, but if you're a little bit intimidated, don't panic. I can't have the obvious graphic on here for copyright reasons. I could have put 42 on there as well while we were at it, but hopefully that's the case. And with that, I'll be up here afterwards. I have business cards as well if you want to email me questions afterwards. And thank you so much for coming here, and have a great rest of the conference.